Hey guys, welcome back to my channel. In today's video, we are going to learn about GCD or HCF. GCD is basically greatest common divisor and HCF is highest common factor, right? So let's say two numbers are given to you like 4 and 10. Take all the factors of 4 and all the factors of 10. For 4, 1, 2, 4. These three will be the factors of 4, right? So for 10, there will be 1, 2, 3 cannot be, 4 cannot be, 5, 6 cannot be, 7 cannot be, 8 cannot be, 9 cannot be, 10, right? So these are the factors of 4 and these are the factors of 10, right? So highest common factor or greatest common divisor, right? So which is the highest common factor? Common, it should be common in both of them. So see, 2 is there, 2 is there. See, 1 is also here, 1 is also here. But why not 1? Because we are taking the greatest one, right? We are taking the highest one, highest common factor. So that's the reason GCD of 4 and 10 will be 2. So similarly, let's go for some other example. Let's go for some maybe 3 and 9, right? So for 3, factors are 1 and 3, right? For 9, factors are 1, 3 and 9. 1 is there common in both and 3 is there common in both, right? 1 and 3, these two are common in both. Which is the greatest one? 3, right? So GCD of 3 and 9 will be 3, right? So how we are going to implement this? Let's say two numbers are given. Let's say A and B is given to you. You will have to find basically the greatest common divisor of A and B, right? So you will iterate from I equals to 1 till minimum of A and B. And then you will be checking whether I can divide both A and B. How you will be checking? In if condition, you will be writing something like A modulo I equal to 0 and B modulo I equals to 0, right? That means I is dividing both B and A completely, which basically means I is the common factor among A and B, right? So let's store it in some vector, and then after that we will just take the maximum of this vector, right? Otherwise you can do one more thing. So we will maintain a variable, let's say GCD, and let's place 1 first of all, and then as we move forward we will change the GCD, right? So if there is some divisor that divides A and B completely, we will override this, right? So let's say in future, let's say 2k, right? So GCD will be overridden to 2, and let's say in future hypothetically 4k. So you will be writing like GCD equals to I. That means previously it was 2, but right now it's 4. So ultimately GCD will be storing the maximum common divisor, right? Since it is iterating from 1 till minimum of A comma B, it will be storing the maximum of common factors between them. Now let's see why we took the minimum of A and B, right? Why we took this? Let's understand this by a small example. So let's take some other example. Let's take maybe 4 and 12, right? So see, what I'm going to do, I'm going to check from I till, let's say, let's not take minimum, right? Let's take the other value. Let's take 12. I'm going to iterate from I equals to 1 till 12, and I'm going to check whether I can divide 4 completely and I can divide 12 completely, right? So at first I will be 1, right? So let's maintain a GCD 1, Okay, so 1 will anyway satisfy these both conditions because 1 will of course divide 4 and 1 will be dividing 12 as well. So GCD will be 1 again. When I equals to 2, GCD will be 2 again. Let's maintain GCD here. Why? Because 2 divides 4 and 2 divides 12 completely, which means 2 is a factor of 12 and 2 is a factor of 4 as well. And then moving forward, when I equals to 3, it won't go inside this. It won't go inside this block. Why? Because 3 is not a factor of 4, but 3 is a factor of 12. But still, since there is an AND operation, both the statements should be true. So 3 is not a common factor, right? So let's move forward. I equals to 4. Now 4 can divide 4 completely, yes. 4 can divide 12 completely, yes, right. So both the conditions are satisfied. So GCD will be overridden to 4 now, right. So now GCD is 4. And now when I increments, I will be 5, right. So can 5 divide 4 completely? No. Can 6 divide 4 completely? No. Can 7 divide 4 completely? No. Why? Because these numbers are greater than one of these numbers. Right. So we don't have to check after 4. Why? Because anyway after 4, whichever number comes, that cannot be a common factor. That can be a factor for this, but that cannot be a factor for 4, right? So we will just iterate from 1 till the minimum of these two. In this case 4, right? So in this only you will get to know the common factors and you will take the greatest among them. So let's write the code. Int a comma b, we are taking a and b. Then we are initializing a variable. Let's say GCD. GCD equals to 1 at the beginning, and we are going for a for loop. Int I equals to 1, I is lesser than minimum of a comma b, right? So this is an inbuilt function that will be giving the minimum of a and b, right? And then I plus plus. Here we are going to check if I is dividing a and b completely. Basically we are checking whether I can be a factor of both a and b, right? So a modulo I equals to 0 and b modulo I is equals to 0. If this is so, then we are going to reassign this GCD equals to I. At the end, we will be having the greatest common divisor, right? From 1 till minimum of a and b it will go, right? So on the way, the numbers are increasing. So GCD will be having the greatest common divisor, right? So let's print GCD and we'll be getting the answer. So let's say I'm giving some input. Let's give 4 and 10, right? The answer is 2, right? Let's give some other numbers 4 and 12. The answer is again 2, but it shouldn't be 2, it should be 4. Okay, I'm not including that 4, right? So I should give equals to here. We are basically going from 1 till 4. We shouldn't exclude that. So let's run once again. Yeah, 4k. So the time complexity of this code is basically O of n, or to be specific, O of minimum of a comma b, right? Whichever the number is minimum, the iteration will be going for that many times.